Hi everyone, so today we're going to see the Kerberos protocol, which is an authentication protocol developed by MIT, and this presentation is elaborated by Adil Khalil, Nizar Siddiqui, and myself, Hamza Nadir, and it is supervised by Professor Marraqi. So we're going to get into a bit of history of this protocol as well as the basic mechanics with all different messages and the authentication phases, as well as the advantages that made him very useful in a lot of technologies and the limitations that prevents it from being useful in all the situations. So the first question that would cross our minds is, what is Kerberos? And the simplest answer to this is Kerberos is a network authentication protocol. It's designed actually by MIT in 1980, and it's actually designed to provide a strong authentication for client-server applications just by using a secret key cryptography. And the Kerberos protocol itself uses a strong cryptography, as I mentioned before, so that a client can prove its identity to a server and vice versa. It means that the server also can prove its identity to the client across, of course, an insecure network connection. And after a client and a server have used the Kerberos to prove their identity, they can also encrypt all their communications to assure privacy and data integrity as they go about their business, of course. And the Kerberos protocol is available in two types of licenses. There's the open source, and there's also the supported commercial software. So why would use the Kerberos protocol, not any other protocol, for the authentication process? Well, the full definition of what Kerberos provides is a secure, single sign-on, trusted third-party mutual authentication service. What does that mean? So let's break it down into parts and quickly describe each one. Well, from a security perspective, Kerberos is secure since it never transmits password over the network in the clear. And there's also one thing that it's unique about it, which is its use of tickets, time-limited cryptographic messages that prove a user's identity to a given server without sending passwords over the network or even caching passwords on the local user's hard drive. And one of the greatest features about Kerberos is the single sign-on, which means that a user only need to log in once to access all the network resources that support Kerberos. And Kerberos in its basic mechanics is relying on a trusted third party. And trusted refers to the fact that Kerberos works through a centralized authentication server that all the systems in the network trust. So in order to ensure an integrity between the client and the server, Kerberos came with a great feature, which is the mutual authentication. It ensures that the service the user is communicating with is genuine.
Now, how does Kerberos work? So, in any authentication situation, you really have three different parties that are involved. First is the client. Now, sometimes that's a client computer, but more frequently it's an actual user who's sitting at that computer and trying to access some resources. Then there is the resource that we are trying to access, and in this example it will be some files on a file server. And there is the KDC, the Key Distribution Center. Now, in an Active Directory network, that's an Active Directory domain controller. And this is the guy that really kind of brings everybody together. Interestingly, in Kerberos, there is no communication between the resource and the KDC. That doesn't need to be, because the client takes the majority of the processing burden in Kerberos, which kind of distributes that authentication workload across the network, but it does so in a way that is secure and trustworthy, as we're going to see. So things kick off when the client attempts to actually log on to the network. Here is how that works. The client constructs an authenticator, which is a special little package that says here is who I'm claimed to be, and some other information including the date and the time. Now, those authenticators are only good for a certain period of time. That way, they can't be captured and then replayed back on the network by an attacker. So this will represent that authenticator. Now, a portion of that is unencrypted, such as the user's username and so forth. That way, when this gets sent off to the KDC can see who's trying to authenticate, but a portion of it is encrypted using the user's password. So that's what this pin key will represent, and that's what this pin clock will represent, that the user password, which is known to the user, has been used as an encryption key. This is an important concept because it emphasizes the fact that Kerberos doesn't transmit your password across the network. Instead, it uses it as a shared secret. Now, shared secret simply means that when this thing is sent off to the KDC can open it up and can see the contents in clear text. Okay, this is who that user claims to be. I'm going to go to my database and look up for their password and see if I can use it to decrypt that authenticator. If I can't, well, then this was clearly encrypted with a password other than the one I know about. So this user isn't who they say they are. If I can decrypt it though, then this user must be who they say they are, because they've got the correct password. So from this point on, I don't need this authenticator anymore. It can actually just completely go away. Instead, I'm going to create a ticket granted ticket or a TGT. Now, I, as the KDC, have my own encryption key that I'm going to use to encrypt a portion of this TGT. I've already gone through the laborious process of looking up this user and making sure they are who they say they are. So I'm going to save all that information in here, but I'm going to encrypt it using a key that I only know. Then I'm going to transmit this whole thing back to the client, and they're going to store it in a special area of memory called the Kerberos drive, which is an area of memory that cannot be swapped out to the disk. It always lives in memory, and that way if the computer crashes, this information hasn't been saved anywhere persistent. So now the client is logged on, they're ready to go to get what they want from the file server. But before, we need to have a ticket for the file server. So we're going back to the KDC, and what we're going to do is to send back this TGT to the KDC along with a request. Hey, I want a ticket for the file server. The KDC does not have to look up my information again. It simply uses its key to decrypt the TGT it gave me earlier. If it decrypts successfully, then it knows that this is the information it generated itself previously. This TGT usually goes for 8 hours by default, so periodically they will have to be destroyed and renewed. That way the KDC gets an opportunity to reevaluate my identity. But it does not have to do that every time, which saves some efforts. The client actually does keep a copy of this in its Kerberos tray and send off a copy to the KDC. The KDC now know who I am, thus can generate a ticket. Now here is the cool thing. Because the file server is also a member of the domain, the KDC has its logon password, which it will be used to encrypt this ticket. Remember, there is no communication between the file server and the KDC. Instead, this ticket is created by the KDC and given to the client, who stores it in the Kerberos tray. Now, for the next 8 hours, while that ticket is still good, anytime the client needs to access something on that file server, all it has to do is to create a copy of that ticket and send it to the file server. The file server says, I don't have any idea who you are. I've never seen you before. So I'm going to use the password which I know to decrypt this ticket. If I'm able to do so, then this ticket must have been generated by the KDC because that's the only other person that knows my password. That tells me as the file server that this is a legitimate ticket. So I'll go ahead and open it up. It will tell me your username and what groups you're a member of, and I will use that information to decide what you are allowed to access. And every time you come back to me, Mr. Client, you are going to need to resend me a copy of this. And that way, the file server, don't have to store all this garbage on memory, because the file server is working with hundreds, potentially thousands of users. If it had to keep all those tickets, it will be a huge pain on the neck.
So as we saw previously, the Kerberos protocol is very reliable when it comes to the authentication process because it guarantees the security as well as the integrity of the credentials of its users. So this opens up the opportunity for a lot of big names in the tech industry to implement it in their services and also in their products. One of the examples that we can think of is Microsoft because they started implementing this protocol as the default authentication protocol since Windows 2000, and it's the essential component for Windows Active Directory as well. There's also a great example that we can think of, which is the Data over Cable Service Interface Specifications, which is a standard interface for cable modems, the devices that handle incoming and outgoing data signals between a cable TV operator and a personal or a business computer or television set. So they use this Kerberos protocol also to access their networks. So as it is the case for each and every protocol, Kerberos also have some downsides to it, which prevents them from being useful in all the situations. And those downsides make it difficult to implement the Kerberos protocol, because this protocol assumes that each user is trusted, and its primary goal is to prevent an encrypted password from being transmitted across that network. However, if anyone other than the proper user has access to the one host that issues tickets used for the authentication, which is called the KDC, the Key Distribution Center, the entire Kerberos authentication system is at risk. There's also the time stamping issue because all the machines on the network must be synchronized. Otherwise, the time and the life of the tickets might be distorted, and no longer authentication will be possible because the validity of the Kerberos tickets is partly based on a timestamp. And there's also one thing with the authentication server, because if this one is compromised, an attacker can access all the services with a single login. And an attacker can also use it to decrypt other tickets and access different services. And when it comes to the authentication process, Kerberos only encrypts the authentication phase and does not encrypt the data which is transmitted during the session. So this is another issue with the Kerberos protocol.
In this part, we will see how to set up and configure the Kerberos protocol on Ubuntu Linux, and we will start by setting up the Kerberos server. A central part of the Kerberos trusted third-party authentication scheme is the key distribution system, or as known as the KDC, which is a centralized repository of user password and information. So before deploying Kerberos, a server must be selected to take on the role of the KDC. Physical and network security will be critical for this server, since a compromised KDC compromises the security of the entire realm. Each server in the Kerberos authentication realm must be assigned a fully qualified domain name that is forward compatible. So to check the default domain name on this machine, we're gonna type host name. And to check the FQDN, we're gonna type and as we can see, we need to change that. A particular computer's host name can be changed at any time. So to set the initial host name or subsequently change it, we're going to execute this command. and we're going to set the host name to KDC dot, and to check the host name again, we want to type host name, and voila, as we can see, the host name has been changed. Also, Kerberos is a time-sensitive protocol, so if the local system time between a client machine and the server differs by more than 5 minutes, by default, the workstation will not be able to authenticate. So to correct this problem, all hosts should have their time synchronized using the same network protocol system. And so we can check that. We can go to time and date settings, and we check automatically from the internet. This is also for the client. Time and date setting automatically from the internet. So for the sake of the simplicity of this video, we will create an MIT Kerberos domain with the following features. So we're gonna set up the IP address for the client and the host name. Also, we need to set up the KDC and the server. The first step in creating a Kerberos realm is to install the Kerberos KDC in the Kerberos admin server packages. So from the terminal window, we're gonna install the KRB5 KDC in the admin server. So here we're gonna enter our Kerberos realm. Type OK. And for the server, we had for the admin, and we're gonna click OK and let it set up. The questions asked during the installation are used to configure the etc-krb5conf file. So if we need to adjust the key distribution system settings, we're gonna simply have to change this file. We're gonna type edit, and as we can see, the default realm is set to fsr.com. And all the settings are here. So we're gonna click save. Next, we're gonna need to create a new realm with the following command. Here we need to enter the KDC database master key. Re-enter it again. Once the KDC is properly running, an admin user or admin principal is needed. So to create that, we're gonna type Now we're gonna add the principal. We're gonna enter a password. And we're done. So to quit this console, we need to type quit. And we're back to the command line. Next, the new admin user needs to have the appropriate access control or the ACL permissions. The permissions are configured in the following file. Here, we're gonna add the user. I'm gonna save the changes. This entry grants root/admin's ability to perform any operation on all principals in the realm. We can configure a principal with more restrictive privileges, which is convenient if we have a junior staff we don't need to give the full access to. Now we're going to restart the Kerberos server for the new ACL to take effect. To test these changes, I'm gonna type gonna enter the root password. After entering the password, we're gonna use the keylist utility to view more information about the ticket granting service. This section covers configuring a Linux system as a Kerberos client. This will allow access to any Kerberos server once a user has successfully logged into the system. To install the Kerberos client on Ubuntu, we're gonna need to run and we enter the root password. Here we need to set up the default Kerberos realm. And set up the server. And also the admin server. And we're done for this part. We can test this configuration by requesting a ticket using the keyinit utility. For example, and we're gonna enter the password. And we're successfully logged in. To test this, we're gonna type when a ticket has been granted, the details can be viewed using the keylist command. The installation and configuration of the Kerberos server and client is relatively simple and fast, and proves to be highly efficient with single sign-on. So for adding additional services, it is easy as well. The requesting and granting of these additional tickets is user transparent. One of the specific services is connecting with the SSH to different servers to which Kerberos provides an authentication mechanism for additional security. Authentication is a critical point for the security of computer systems. Without knowledge of the identity of a user requesting a service, It is difficult to decide whether it is safe for the service to be allowed, and Kerberos protocol allows the authentication of users and network system, ensuring a certain degree of safety. Of course, Kerberos isn't the only encryption protocol available. There are multiple ways to encrypt data, and this holds true for many types of different applications. But with a product that has been researched and developed for over 8 years now, it is generally expected that Kerberos should be well polished. This can be seen by looking at all vendors who are using it, such as Cisco, Microsoft, Apple, and many others. Thank you for watching.